Hello students, good evening. Our instructor is going to join in another 5 minutes. So please don't leave the session. Thank you.
Yeah. Hello.
Yes, sir. Good evening.
Yeah, good evening, madam.
Yes, sir. Your voice is clear. You can start.
Yes, ma'am. Yeah, fine. Thank you. Thank you very much.
Okay.
Yeah, hello, students. Good evening to all. And today's session is pointers in C. So this is very, very important topic, as well as people will feel that a little bit difficult for understanding like that. Okay. So I'll explain all the topics, each and everything very clearly. And also you should practice. Okay. The pointers and all, if I tell you one or two examples, you should practice with various kinds of examples. Okay, then only you can able to understand clearly. Yeah. So let us move ahead. What exactly the pointer? The pointer in C language is a variable which stores the address of another variable. See, generally, these pointers where we can work with that. So far, whatever the variables we have declared, and whatever the variable we are declaring, and we are storing the data into the variables, and we are printing the values from the variables. That's it. Fine. But now we need to work with some memory management. Like the whatever the variable we are creating, at the time a memory will be allocated, that we call it as an address of the variable. Okay. So for every address, if the value is available into the address, how can we work with the address instead of direct value? That we are going to see in these pointers. So here, how to declare a pointer? Simply by using a asterisk symbol. Okay. So these variables can be any type, either integers, characters, arrays, or functions, anything. Anything we can mention is with the pointers. So say for example, here if I give you the value 10 in the variable n, okay, so how can we print the address of the value, address of the variable? So let me explain with a small example. So for example, if you take one variable, you just declare variable as a int a, right? So generally we are storing a value into the variable. So now what is the value of the a? 10. Fine. Now when you create like this, some address will be created. Like I'll show you. No, I'll take the paint. Yeah. Whenever you create a variable a equal to 10, immediately a memory will be created like this. Like this. Assume what is the variable name? A. So what is the memory? Assume that the memory address. What is the address of for every memory location we have some address. Assume that it is 1000. For understanding, I'm saying, otherwise the memory will be there in hexadecimal. What is hexadecimal? Maybe it's a combination of 0 to F, right? 0 to 9 and A to F. Okay, it will be combination of F, A, 1, 2, like this. The memory address will be displayed in the form of hexadecimal. Okay, it depends on the system. System to system, the value will be varying. Okay, fine. Now, what is the address of A? Once if you create A equal to 10, what is your value? Whenever you say int A equal to 10, if you assign like this, then the value will be stored here, 10. Now the thing is, do you want to print the address of A? Simply we are using ampersand. What is the symbol? Ampersand A. Always ampersand A refers to address of A. This is a very clear point. If you want to get the value of A, then simply we are using A. These two we will see. Okay. Yeah, while printing this value of A, what is the format specification we are using? Percentage D we are using, right? Percentage D we are using. If you want to print address of the A, then we can use ampersand U, or you can use ampersand X. Ampersand X. Okay, let's see. First, you should understand the value of A and the address of A. Fine. Now, where is the pointers concept? Okay. So now, when I give you the input to you, instead of giving the value of A, I may give you the address. If I tell you my address of so and so particular value, my address of the variable. If I tell you address of the variable A, if I give you as an input to you, how will you find the actual value of that particular variable? Okay. For every person, you have some address, right? Your flat number, in case of gated, in case of apartment. Okay, so and so location, so and so apartment, so and so block, so and so flat numbers, like that. That is your address to find a particular person. Likewise, if you want to find a particular value of the variable, if you know the address, finding is very easy. Okay, fine. Now, if I give you 1,000 as an input, how will you get the, how will you point to the value of the way? Simply, we are using asterisk symbol, star symbol. This is a pointer symbol. So, yeah, pointer. If I say P, what is the P? Assume that you have P value is, if you give input P value is 1,000. If I give you the input is 1,000, then nothing but pointer. You want to get the value of the P, then what you can do? Value of that address, what you can do? You should use pointer. That is the purpose of the pointer. That means when you have the address, then if you want to retrieve the content of this address, then use pointer. Now, indirectly, what does it, pointer P is equivalent to? Pointer. What is the P? P nothing but it is ampersand A, right? P nothing but ampersand A. That means if you want to get something data, how can you get pointer of ampersand A? If you are not using third variable, directly you can use like this, pointer of ampersand A. That means what? If I give you an address, you will get the value. Okay, that is the purpose of the pointer. Let's see some more examples where we can exactly useful the pointers. I'll tell you some more examples in the next upcoming examples, more for better understanding in the practical examples. Now you can understand here int A. Now if you want to print simply value of A, what you are doing so far, print percentage D, value of A is percentage D. Simply I can say backslash comma A. I'll get like this. Clear? That everybody knows. Only you want to print address of A, then what you will do? Printf address of A is percentage U backslash comma ampersand A. Let's see these two. After that, we'll see what is the purpose of the pointer. Okay, let me show you. We will have, we'll create one file. Like simply I can say example of pointer as include stdio.h. I can say I am going to create a structure, yeah, then return of 0. Fine. Now you just try to understand about the pointers. Just I can say A equal to 10. This everybody knows that. Okay, simply I'm going to print value of A is percentage D backslash n comma A. Clear. Now, if you want to get address of A is, use %u, comma, ampersand A. So how to use address? Using symbol ampersand. Yeah, while using scanf, you know how to use, right? Don't get confused. Generally, people used to read a %d, comma, ampersand A. That means what? We are storing in the particular address location of A, the data. Okay. So now I want to print with the ampersand A. Then you see what is the output. I'm going to save this pointer, I can say all the examples P1 like this, P1, P2 like this, I'll save. Yeah. And let me run this. So you can try to understand. Yeah. What is your output? Value of A is 10 and address of A is some address location, we got it. Okay. Fine. Now, the same thing, if you want hexadecimal, then you can use X. You can use X, you will get the values in the form of hexadecimal, the address location. See, 62FE1C like this. This is like hexadecimal. Hexadecimal, nothing but what? 16, right? 0 to 9 and A, B, C, D, E, F. Okay, the values will be displayed up to the with values of 15. Decimal values and octal values, binary values, hexadecimal, right? We are printing in the form of hexadecimal, the address value. Fine. Now, assume that you know the address, right? So if you want, if I give you the input is ampersand A, how can you get the value of A? Okay, so that's why I want to use a pointer symbol. Simply I can say pointer P. Simply I can say pointer P. Once if you know the pointer P equal to ampersand A. That means what? Simply in the P, I'm storing P is of type storing address, right? That's why I'm using declaring the variable as a pointer type variable. How can you declare a variable as a pointer? Simply a variable is preceded with a pointer symbol, asterisk symbol. Then I can say P is a variable of type integer which points to some integer data type. Fine. Which points to some address, right? Which address? Whatever the address you consists of, the P. Now here in this case, P consists of address of A. Okay. So simply you can print the value of A. How will you get the value of A? Simply I can say value of A with pointer. With pointer. I can say %d only, comma, pointer P. Here itself we can use pointer of ampersand A also. That's not a big deal. Okay. Pointer P. Then you will get the value. What is the value you got? 10. Value of A is 10. The value of A with pointer. Right? Same thing we got it with the pointer. Same thing we got with the pointer. That means whenever you are using the pointer, the only single point you can keep in your mind, if there is any address, within the address, the value will be displayed. Okay. If I give you an address as an input to this variable, if I use pointer, you will get the content of that. That's it. I hope you understand about this. Simply, I just printed with pointer P gives the value of A, that is 10. Okay, fine. Now let me go for another topic. Yeah. So if you observe in this PowerPoint slide, then I mentioned int n equal to 10, int pointer P equal to ampersand n. Okay. So variable P of type pointer is pointing to the address of the variable n, of type integer. Okay, fine. Now let's move. Here, this diagram easily understanding. By observing this diagram, you can understand that. Okay, what do you understand? There is a variable. What is the variable? A. A is a number variable. A is a number variable which consists of some value 10, and that address location is 1001. Okay. So now this address is stored into the variable P. What is the P? Here pointer variable. Okay. P itself has some memory location. That address is FF1. Assume like that. Okay. Yeah. So this is the way we are assigning the address of A into the variable P. Okay. Fine. Yeah. So this is declaring a pointer variable. You can declare with the integer pointer A, char pointer C, whatever it may be. Okay. Fine. Now, next, this example we have discussed, right? What is there here? Int number equal 50, pointer P. We are assigning ampersand number 50. That means address of this number. I just printed. Address of P is P, directly P. If I print P, then you will get the address. Then if you get the value of the variable, then simply you can say percentage P. Okay, simply just now we have discussed about this program. Now, some people may think that what exactly the purpose of this pointer? Why I have to use these pointers? Okay, same operation only, na? Either you can use it with pointer or without pointer, you are getting this, right? Yeah, there are plenty of the advantages while using this. Okay, some dynamic memory allocation. Whenever you want to allocate the memory dynamically, okay, so we are using malloc and all. It is possible with help of the pointer only, right? That means as an array is a static memory allocation, as we discussed earlier. But if you want to allocate memory dynamically, we should use pointers. That is one thing. And sometimes I'll give you a small, that is anyhow the next topic will be there. But before going to further, people should know what is the purpose, why we are, by making complicated of using pointers, why we are dealing with the addresses instead of value directly. You will get some kind of, confusion, but I'll explain you with a very good example. I'll show you here. Yeah. Now, assume that this concept also we call it as call by value. Okay. Call by value, call by reference. Assume that you want to swap two numbers. Okay. So that you will better understand the purpose of the pointers. Okay. Say for example, this is A having the address 1000 and value 10. I took another variable B, that next location is, assume that it is 1004. Why? Because 4 bytes will be occupied. My value is 20. Okay. You try to understand this example, what I'm trying to say. I'll write some kind of program that is called swapping. Okay. That means I took value of A is 10, value of B is 20. Okay. Value of B is 20. I have written a function. Okay. So that I'll write in the notepad. Okay. So assume that I'll write here the swapping program. You know how to use swap, right? Int A comma int B. How I'm going to swap? I'll take another variable int temp. Okay. simply assume that what is A value? 10 comma B value is 20. Okay. How I can swap? Simply try to understand this B value I want to store into the temp. This B value I'll take into the variable temp. So that tell me what happened. Now B consists of. So all of you try to understand about the swapping. This is also very important point, right? Assume that how I'm going to swap, I'll tell you. Based on that, I'll write the statement, right? You don't by heart it. How I'm going to swap? How can I swap two numbers, right? That is, I'm telling you now, using temp variable. And also I'll tell you how to use without temp variable also. This is the temp variable, right? So now this A value I just stored into the temp variable, right? Now what is the temp which is having 10? Now my statement is temp equal to A. But the next step is, now A is free, right? I just assigned B value into A. Now what is that? What is the value of A? Now B is there in the A, right? Now A becomes 20. Now I want 10. Anyhow, the 10 I kept here, right? In the temp. This value I'll put into B. That's it. This is the way I can swap. So how can I write the same thing into the programming? What is my first step? Simply A value I want to put into temporary variable, right? I can say temp equal to A. And then B value I can transfer to A. Okay? A equal to B. That means what? Right side values which is stored into the left side, right? As you know. Now B value stored into A. And then what is the final step? Temp value storing into the B. Okay? So finally B equal to temp. Temp value stored into the B. Then values will be swapped. Then assume that in the main program, I have these variables. Then you just printf after swapping, if I print A and B, what is the output? You tell me now. So before that, what I do, I just apply the function swap. Swap of, I can say simply, I can say into A comma B, I can give you, or directly I can say 10 comma 20 if I pass. Okay? If I pass 10 comma 20. Or simply I can say A comma B. Assume that A comma B. Here I can say, or simply I can change here, X and Y. Same variable you can use, different variable you can use, not a issue. I can say X and Y. These X and Y are passing to here. And after swapping, then I'll just use X and Y values printing. Okay, I have applied, right? Just X and Y I pass it to here, and then I swap, and then I'm just printing the X and Y value after the function, right? Now, please tell me what is the A and B value? What is the A and B? Somebody is typing Lahari and all. Okay, 20 and 10. Okay, A equal 20, B equal 10. Somebody is typing. That is swapping, right? Yes, like X and Y. No issue. X equal to 20, Y equal to 10. Yes. Whatever it may be. Yeah, functions, it is already covered. Functions already covered. You can see in the YouTube where the functions are already covered, that videos are there. Okay, that you can see in that video. So now, what I'm trying to say, these values are there, right? My dears, you should understand one point here. You should understand one point here. Even though if you swap like this, until returning your value, you should return something like, in case of a plus b, I can say return of a plus b, right? If you return, those returned value will be taken into another, called function, then only this will be applied. Keep in your mind one point, right? Yes, now I'm not using any return statement. Then is it applied here, the swapping? No way, the swapping will not be applied here. Simply x value is, even though after calling the function, here the values are changed, but that is not affected in the main program. Keep in your mind. Finally, my output is x value 10 and y value 20 only. Those swapping changes are not affected here. Why? Why means, if you apply return, can I do return of a comma b? So that can I return two values? Yes. And another problem is, this is also wrong. Why? Because as per the functions norms, the rules and regulations, a return statement can return only one value at a time. A plus b is having only one value, but whereas return of a comma b means 10 comma 20 or 20 comma 10. Here, in this case, a value is 20, b value is 10 only. In this function, the values are changed. A value is 20 and b value is 10, fine. If you return those values, then only here it will be affected. But is it possible to return two values through the return statement? No way. No function can return more than one value at a time. But how? I need two values, right, for swapping. How can it is possible? Yes. Yeah, that is the problem. I think you understand. Okay. Yeah, these problems, how can we solve? By using pointers, it is possible. By using pointers, it is possible. That I'll tell you the next topic. Say, for example, if I use the explanation, I'll tell you the next, not next class, in the end of the session. Yeah, if I pass address, that means what? 10 value address and 20 value address. Once it is the address, what kind of variable this should be? You are passing, you are giving an input is an address, while you are storing, what kind of that is? My dear students, if it is the integer, if you are storing, this variable should be integer. If it is a float, this should be float. If this is an array, this variable should be, formal variable should be array. If this is a structured variable, this should be a structure. Are you clear? Similarly, whenever you give some kind of address, that should be a pointer. Then only you will get the value of that, right? So, with the help of this, you are dealing with the address. It is possible, swapping. That means, how it is possible? Yeah, I won't change the values of the variables. Simply, I can change the address. Okay, I can change the address. That means, okay, this address is referred to this and this address is referred to this. Then whatever the address is referred to the any variable, whatever the content is there, simply I can print it. I no need to refer, right? I no need to return statement. Without writing the returning statement, simply if I change the address, so the A is referred by this address and B is referred by this address, then simply your values are changed. If I print something, the value with this address of 1004 is what? 10. What is the value at this address of 1001? 20, like this. I can, get these swapping values with respect to the address. That I'll give you more elaboratedly. So here, I just given a small example for understanding why people are going for the addresses, right? Yeah. Later, and also if you want to create different, memory allocations, one memory is allocated. After that, another size of the memory is allocated. After that, another memory size is allocated. That means what? What does this mean? this address is stored here. Then this address is stored here. Like this, you can have memory is creating dynamically. How can we do that? These are all I'm going to explain in the upcoming sessions. So now keep in your mind, the pointers is very important. Try to understand how can we work with the pointer and what are the various use cases we have and what are the pointer arithmetic, pointer, pointer to pointers and pointer to arrays, pointer to functions, okay, and call by value, call by references, and what are the various types of the pointers. These are all the topics we are going to address now. Okay. Yeah. So let me go with another point now. I'll explain in detail. Okay. That is the next part. So now I given just a clue, like, the purpose of the pointers, you should understand some example. That's why I have given this example. Okay. Now, this point, what is that? What are the various types of the pointers? We have various types. Out of that, we are going to discuss 4 types of the pointers. What is this? Null pointer, void pointers, wild pointers, and dangling pointers. Okay. Yeah. What are these individually? We'll see. What is a null pointer? This is very important in future classes. Whenever you create, dynamic memory allocations, at the time we should create a null pointers. What does it mean? See, what is a null pointer? If we assign a null value to a pointer during its declaration, this pointer is called null pointer when you assign null. Okay, so you should understand very clearly, null is different, 0 is different, right? Is that both are same? 0 nothing but it has some value. 0 is a value. Without assigning any value, okay, without assigning any address, there null, nothing is there, no address, we call it as a null. Okay. Yeah, many times unknown values are referred by using nulls also. Fine. I'll give you an example. This is a null pointer. That means I can assign a null will be referred with respect to the capital letters NULL. Null. That means what? Okay, I'm not assigning anything. Okay, null address. Okay, how can we see this? Simply you assign pointer p equal to null. You can you can see this value. Okay, value inside the variable is it will not print anything. Okay, it will not print anything. If you want, I can show you one small example. Yeah, simply this is the null pointer. Nothing is there here. Simply pointer ptr equal to null. The value inside the variable ptr is ptr. Okay, we don't have any value, right? That address is nothing. Then you can print like this. Yeah, 0. The value inside the variable is 0. Okay, fine. Now, see, sometimes you need to, the next one is void pointer. And that's what I'm telling. That's what I'm telling Mr. Venu. I'm going to discuss about the null and the void. Okay. Yeah. Null means no address, whereas void means, okay, any type of variable I can take, any type, like the void will take either integer or a character or a float or anything. Okay. This variable can consist of any type of data type. Whereas null nothing but it is null address. When a pointer is declared with void keyword, then this pointer is called a void pointer. To print the value of this pointer, we need typecast this pointer, right? Whenever that means any type it is possible. Like if you want integer, you can do. If you want float, we can do. If you want char, you can do. But before printing, you should do some kind of typecasting, right? Typecasting, you just convert it into int of, float of, like that. Okay, fine. And what is the size of this? What is the size of the null pointer? Yeah, this is kind of interview questions people will ask. What is the size of the pointer? Okay. Yeah, once if you create a void pointer, not null, void pointer I'm talking about. Yeah, void pointer, simply you can display the size of the pointers. Yeah, you can say I just declared. See, whereas in null pointer, how I declared? I just created as an integer. Okay, with the data type integer, pointer equal null, the value is 0. Whereas in the null pointer, sorry, in case of void pointer, the data type is void. See, depends on the situation. Yeah, see, generally we can use void main also, right? Void main also. In that case, it returns nothing. Generally, we are using, right? Void nothing, but if you use instead of main, instead of return statement, I can say void. At the time, I no need to return anything. Okay, no return. But whereas here, if I use void pointer, okay, that means this pointer variable p, I can store any integers, characters, floats, and anything. Okay, anything you can create, and also including null also I can do. Okay, anything, either null I can store, either integers and floats, strings, anything. You can create one example and you can just simply whatever I shown earlier example, simply assign any integer value, you can print it. Okay, and you can also print the size of p, and simply I'm going to execute this. You will get 8. Okay, the size of the pointer is 8. Okay, like this you can use the void pointers. Then what is the next one? The next one is wild pointers. Okay, wild pointer. A wild pointer is a pointer that's only declared but not assigned any address of any variable, right? These pointers are very tricky and they make cause segmentation errors. Generally, when you declare this, when you declare the variables, you are not assigning any values, only simply declare. At the time, you will not display anything. Sometimes this will cause to errors. Okay, like this. Whenever I just displayed this, I'm talking about, simply sometimes people will declare, but without assigning anything, simply they'll leave it. That's what I'm saying. Okay, at the time, it causes some kind of errors. So whenever you create a pointer, you should be, you should assign some kind of addresses, and you should address some, you should point it to some kind of address so that you can refer to address, you'll get some value in that. Okay, simply if you leave like this, it won't display anything. And here in this case, it won't get any output. Some systems, it may cause to struck this system, and it throw some kind of errors. And here we are not handling any exceptions. Sometimes it will throw the errors. Yeah, here simply it is not displaying anything. Nothing is displaying, right? So these kind of pointers we call it as wild, pointers. These not suggestible pointers, you should not do like this. Okay, you don't use wild pointers, right? Yeah. Now the next one is dazzling pointers. So these kind of pointers, I'm just giving you various types, that's it. These kind of dazzling pointers, whenever we create a memory, or we create an object, like where we can create object, like for every structure we should create an object, and we should access the data through the data member, right? Yeah, whenever you create memory or you create a variable. Okay, whenever you create a memory, the value you are storing, fine. So now at the time, I'll tell you here. Yeah. So assume that a pointer p pointed to one variable, that is a. P1 is, this is P1. P2 is pointer to, yeah, what I will do, I'll create new one. Yeah. So what will happen? Whenever I create a variable in the A, memory is created, fine, right? So if I give some kind of pointer P1, so now P1 is pointing to A. So you take another variable B. That means when the variable B is created, simply you can say int B. That's it. A memory will be created. If you assign some value address of B into P2, nothing but P2 is pointing to B. That means what? P2 is pointing to B, nothing but what? Address of B is stored in the P2. Address of A is stored in the P1. That is the meaning. Fine. Now, after that, C is created. You can, C is created. Memory is created. That assume that this is 1000 address and this is every location is 4 bytes integer, right? So that's why I created. Next location is 1000. Starting is 1004, right? This is occupies 1001, 2, 3. Next starting address is 4, like this. Okay. This address location is 1008. After creating memory, how you can create this memory? Using the function. By default, you can assign the ampersand address, that's fine. Or you can create a memory by using a function called malloc. You can create manually memory allocation by using a function called memory allocation, malloc function. That I'll tell you next session. Then after creating the memory, you can delete those memory. You can delete the memory, okay, by using the function called free. So now my concept is, by using free function, you can deallocate the memory, right? You can deallocate the memory. At this time, a pointer is pointing to some location, which is deallocated. Okay? A pointer is pointing to some memory location, which is already deallocated with respect to the free function. So now I can say a P3 is dazzling pointer. P3 is a dazzling pointer. So which points to the deallocated memory spaces objects. Okay. So this we can call it as a dazzling pointer. Thank you, Aisha. Yeah. So generally people used to think that, pointers are difficult, but if you understand clearly, it is very easy to understand. Now, fine. Now, this is just a concept, just to try to understand. Okay, nothing is there in that. Okay, after memory is free, then when you pointed to that, those kinds of pointers we call it as dazzling pointers. Okay, see, this is the example. In this slide, you can understand simply. So later session also, I can tell you how to create a memory using malloc, memory allocation, right? So in this case, I'm going to create an integer size. That's why typecasting, we call it as like this. If you write int of star, typecasting, okay? With which size we are creating the memory? With the size of integer, I created memory, okay? Which is pointed by, that address is pointed by the PTR. Then I have assigned the value 50. That means PTR is storing the address of the 50 ampersand A. Now the pointer is, now if I print the PTR, what is the output? 50. If I print the value of the PTR, what is the output? Pointer PTR, you will get 50. But now I have removed by using free of pointer. How can we remove a memory which is already created? How can we remove? Which is pointed, that memory location is pointed by the PTR, right? I just remove like this, free of PTR. After removing the PTR, if I try to use pointer PTR, nothing will be there. If I am not using free function, then you should get the value is 50, right? That is the example. I'll show you example of the dazzling pointer. Okay. So in this case, I just created the memory. In the next class, I can show you how to create memory allocation, calloc, okay, realloc, and creating the not only integers, float, characters, and many things we will work on that. Okay, if you create a memory by manually, by your own, not system, internal, it is not created by the system. You are creating your own. That is why we call it as dynamic memory allocation. Dynamically memory, if you want to allocate, at the time you should use the malloc functions. So now for better understanding of the dazzling pointer, I'm using this malloc. Assume that a pointer is pointed to an integer kind of memory space. Now I just assigned the value 50. Now, whenever I assigned address, then yeah, I'll make it, comment of this free without using free. What is pointer PTR? What is pointer PTR? Yeah, address is there in the PTR. If you want the value, then you'll get the 50, right? I'll just run this. Yeah. Yeah, memory is created. After that, after free, yeah, already, I just executed this program. I have removed this one. It is there in the buffer. Now, after deleting the memory, nothing is displaying, right? So, memory is deleted. So, this is the example for the dazzling pointer. Yeah. What is meant by void? I can say in single line, generic. Okay, there is a concept called generic in C++. I'll tell you best example, my dear. Some more people are asking. Say A. See, in the advanced nowadays, okay, in the advanced concepts nowadays, I won't declare anything variables. In Python also, there is no need of declaring variable, right? What is the disadvantage if I declare the variable, my dears? Tell me. If I want to store any value in this, I should tell to the compiler in the starting itself. What is your purpose? You want to store 10.5? That means you should define to the compiler what kind of A, in what way you want to utilize the A. As a float, you should define starting itself. So I don't know. Maybe I can say integer, I can say float, I can say character, I may store array, I may store anything. I don't know A. In what kind of data I want to store, I don't know priorly. Are you getting my point? So these concepts we call it as generic types. Okay, generic types. So this is advanced concept in C++, creation of the generic types and generic classes. Okay, so that means what? I won't say anything, but whatever you want, I can store integers, I can store float, I can store characters, I can store strings, whatever it may be, I can store. Are you clear my point? Yeah, when it is possible, you can say void. Okay, simply you can store any type of data. Are you clear? Yeah, I think one person asked, yeah, are you clear, Vishnu? And also, your terminology may be, sometimes it may be different. Whenever you are using the same void, using the functions time, when you use the functions, at that time, you can say, okay, you are not returning the statement. No return type here. Here I can say no return type. Okay, you are not returning anything. Okay, so that means you no need to write anything. So this function indicates you are not returning anything. Like that it can tell. Okay, and if I say anything written by particular data type, you can say enter something. Are you clear? So if you use functions concept, the meaning is like that. And if you use like this, here if I say integer, but I don't want any return, that's why every time I'm using return 0. Since my main function doesn't have any return statements, I don't want any returning. But even though my function is asking that you are returning something, if I say that I am returning something, you should return. Otherwise, what will happen? My function indicating the return type is integer, nothing but you are returning something. But if you are not returning anything, it is mismatch. That's why simply I can say return 0. Okay, నేను ఇస్తున్నానని చెప్పి నువ్వు కంపల్సరీ ఇవ్వాలి, ఇవ్వకపోతే mismatch అవుతుంది. That's why I'm saying that if you are saying you are giving, you should return. That's it. Okay, so if you're not returning, you can put void. Okay, let it be. And if still any more are there, you can contact personally. I'll give you the more explanation. Okay, fine. Now we're coming to, yeah, these are the dancing pointers, right? Completed types. Now coming to where we can use these kind of pointers, various use cases, right? Yeah, you can use these pointers in the pointer arithmetic, and you can also use with a pointer to pointers. You can use the array of pointers where you can use one of the use cases, call by value and call by reference, right? These topics we will address now. Okay, fine. Now pointer arithmetic you should understand very clearly, and we can do different types of arithmetic operations on the pointers, like pointer incrementing, pointer decrementing. Okay, how can we add, how can we subtract and all, we are going to discuss with the pointers. Nothing but when you increase the address, how it is going to be pointed to the next memory location. That is very important thing. Okay, so yeah, you try to understand here. Yeah, after this session you please execute the programs, then only you can understand clearly. Otherwise it is very difficult, you will forget after this session. Okay, so that's why you should keep on practicing the programs. Now what do you understand about this program? You just I have created two variables. One is the number having the value 10, 50, and another variable is the pointer type variable which is pointed to integer. Fine. Now another variable, I took the p consists of the address of the variable number, right? Fine. Up to this we already executed. Address of p is %u p. Simply you print the p, you will get the address of the number. Fine. Now you are increasing the pointer, you are increasing the address, not a value of the 50, right? If I say p equal to p plus 1, nothing but what? You are increasing the next memory address location. Now you tell me, assume that the address of 50 is 1000. Now what is the value of the p plus 1? What is the value of p plus 1? You please chart. Please chart. Please chart. If the value of the address value is there in the variable p, assume that it is 1000. After increasing plus 1, what is your output? Is it 1001 or what? Yeah, I need a quick responses in the chart window. Okay, yeah, fine. Now, yeah, let me show you about this program. Yeah, when you see this, okay, let me run this program. Yeah, what do you understand here? Address of p is 64877572 something. After that, after increment, my address value is 6487576. What do you understand? It is added 4. It is added 4. Yes, very good, very good, very good. Yeah, most of the people has given. If it is 1001, then it is if it is 1000, then it is 1004. Okay, the value will be 4 values are added. Fine. Okay, why it is like this? You are saying that when you increase the pointer value by 1, it is indicated to the next memory location, next integers, right? Simply if I say in the same example, p1 plus 1 nothing but which is pointed to the p2, that address is 1004. Okay, in case next memory location is character, char C. Assume that char C. Now, what is this? Next location is char C. Every character occupies single, right? Next memory location is char C. That is, if I say P2 plus 1, if the next memory location is char C, character, char C, my pointer is pointed to the 1004. Now P2 plus 1, nothing but what? P2 plus 1. Nothing but 1005. Okay, since character occupies single one byte. Yes, increase based on the data types, right? That is next memory location. Okay, next memory location, next address value. Okay, fine. That's good. Now, so likewise, you can add the address. Okay, fine. Yeah, array also. And also based on this concept, you please try to understand. How can you print the traversing the array elements? How can you traverse the array elements? Now you see, in the last previous class, I also told you, okay, if we have an array of 5, 1, 2, 3, 4, 5, okay. Now pointer P, without pointer also, simply you can say P equal to A. That means what is that value will be stored? Yes. And you should try to understand another point. How can I use array? Traversing an array. Yeah. Now I just created an array having the values 5 elements. 1, 2, 3, 4, 5, right? Simply array of 5 equal to something. If you have assigned, 1, 2, 3, 4, 5, okay, and so on, okay, and so on. So this value is 1, 2, 3. This is very much important, my dears. Please try to understand. Okay, the value. What is this address? A of 0, A of 1, and so on. So, right? A of 1. This is A of 4. This is the array. Okay. Now, assume the starting address is 1000 with 44 added, right? You can add it 444. Now, if I say P equal to A, there is a variable P. Simply, if I assign A value, I already told you in the last class, what is the value of P? Simply, without assigning anything. Simply, if I say P equal to A, is it accepted? Yes, it is accepted. Yes, it is accepted. But it stores the address of the first memory location will be stored. Address of the first memory location will be stored. So this is equivalent to, both are equal. This is equivalent to P equal to, this is equivalent to ampersand A of 0. Both are same. This topic earlier I have discussed. Both are same. Both are same. Now, with this previous example, as you understand that, if I increase every value by 1, 1, 1, 1, with this P value, if I increase P value by 1, if I increase P plus 1, the next one is P plus 1. P nothing but what is the value? Assume this is 10, 20, so that it is easy to understand. Okay, 10, 20, 30, 40, 50. Okay, if it is a P, what is the value of the P? Address of 0. If it is a pointer P, you can say, okay, value 10, right? Yeah. Let's see now. Now, with this, you should try to understand. Okay. So, array pointer P consists of what is that? The value. the first value 1 is there. Okay. Now, yeah, you should try to understand here. Now, what happened? I value. Now, what is there in the pointer p equal to array? Assume it is 1000. Assume it is 1000. Pointer p nothing but value 1. Now, pointer p plus I means what? P is having 1000. I value 0. That means 1000 plus 0. Pointer 1000 means what? Value 1, right? Pointer 1000. Next, I becomes 1. I becomes 1. Now I'm asking p plus 1. P plus 1 means what? P plus 1 means what? Next memory location, right? That's why I given the previous example, p plus 1, p plus 2 values. Next memory location, that is 1004. What is the value on the 1004? Number 2. Next, what is p of I value 3? P plus 3. What is the p plus 3? Next value. Pointer p plus 3 means what? Next array value. Okay, like this. So, how can we traverse the array with respect to the pointer? I hope you are clear with this. I hope you understand. Okay, traversing the array elements with respect to the pointers. Okay, yeah. Now let me run this program. Let me run this program. Yeah. So I can, values I can say here, instead of 1, 2, 3, I can say 10, 20, 30, 40. Yeah. Now what happened here? Array of this is also equivalent to into pointer p is also equivalent to ampersand array of 0, as I told you, right? Yeah, this is also equivalent to the first memory location address we are storing. By default, it will store first address location. So first address value plus 0, that means first value. Pointer second memory address location, that is 20. Pointer third memory location, 30, and so on. Okay. So directly what is output? All the values will be printed. So you got 10, 20, 30, 40, 50. Yeah. So this is I just added now previously. Equal to less than 5. Yeah. 10, 20, 30, 40, 50, it is added. Now, with this example, you should try to understand one assignment task. Okay. You take 10 elements. Using the pointer variable. Okay. Using pointer variable, display alternative values. Display alternate values. Okay. Like 10, 30, 50, 70, like this. Alternate elements in the array, you have to print it. Okay. How can you do that? By adding the address value 2, you just do like this. Then you can print alternate. That is assignment task for you. Okay. Fine. So let's move. Next topic is pointer to pointer. Okay. Pointer to pointer. How can we do? A pointer. Is it possible? Already a pointer P consists of some address. Is it possible a pointer itself can point to another pointer? Yes, it is possible. So let me execute here. New. Don't say. Yeah. Say for example, yeah, you take this is A. The address of A is 1000. Address of A is 1000. The value of A is 10. Yeah. Now, if I say a pointer P equal to ampersand A, nothing but what? P is pointed to this one, right? Nothing but what? 1000 is stored in this, right? Address of A is stored in the P. P is a variable which is pointed to the address of A. Okay. So simply I can say what is there in this pointer P? 1000 is there. So now, if through the P, if you want to get A value, through P, you want to get A value, simply I can say pointer A. That's it. I can say pointer A. But, okay, if I ask you your friend address, you are showing first another address. After that, he will show you another address. Then only I can get it 2 times traversing. Okay. So now, there is this address having something like 2000. Let's assume this is another address that is 2000. This is 2000, right? Now this 2000 is there in the another variable location. Okay, that means assume that this is another variable like P, same P only. Okay, through this P, okay, what is the value of the P here? Address of P. What is there? This address of P. It is there here. Now, if otherwise you can say P1. Okay, through this P1, you want to get the value of A. What you can do? Otherwise P only. I can't say P. Okay, simply I can say pointer to pointer. What I can say? Pointer to pointer. Simply I can say, yeah, pointer to pointer, right? Pointer to pointer of P. Fine. That means what? Pointer to pointer. Okay. So this is stored here. So if I want to get this A value, pointer P, then I can say one single pointer, nothing but I'll get this 1000. If I use another 1000, nothing but 1000 address value, then I will get the value 10. How can I do this? Yeah, let me show you pointer to pointer. Yeah, simply I can say A value 10, pointer P, and double pointer PP. Double pointer PP. So, what is the P value? It is address of A. What is the PP? Address of P. Address of P is there in the PP. Now, if you print P, what is the output of the P? Simply you will get address of A. If you want PP, address of P. Address of P, you will get it. If you want value, then I can say pointer P. If I say with respect to P, you want A value, then what you can do? You can say single pointer. You want to get value of A with respect to PP. With respect to PP. If I say pointer PP, then I will get only 1000 or 2000. If I want pointer P, then I will get 10. Okay. So you practice more with single pointer PP, with ampersand. Same thing you can use with ampersand A, or you can use pointer of ampersand directly. All the values you should practice it. Okay. Now let me run this. Yeah. So what is the output here? First one is address of A, right? Where the P consists of address of A. So I got address of A. something. Since I'm using percentage X, the values are displayed in the hexadecimal. And then address of P is some other location, right? Yeah, A, 08. And then value stored at P is 10. Value stored at PP. That means with the help of P, I'm using pointer P. With the help of PP, I should use double pointer. So you can get the, you'll get the value of P with respect to single pointer and with respect to a value of A with respect to single pointer and double pointer. That's it. Nothing will be there. And now, yeah. And as I have shown earlier, that is called, another topic is like, call by value and call by reference, right? That is the last topic in this pointers, and some more examples of, real-time use cases examples and dynamic memory allocations, and how can we, reallocate and how to allocate dynamically and everything. I will explain in the next session. And meanwhile, what we can do, let me, can you practice in the next session what we can do? Now, as I told you in the previous example, you should, this is one kind of assignment, write a C program. Yeah, first, I will run this program, call by value, call by reference. That how can we make it possible? You should practice. Okay. So, example program on call by value. Yeah, I'm going to write this skeleton. Yeah. And then, so as I've shown earlier, simply you try to practice this program. I can say int A comma B, or directly I can use A equal 10, B equal to 20. After that, what you can do, you can apply a swap function, swap of A comma B. Printf after the swapping function A equal to percentage D space B equal to, otherwise you can say percentage 5D, B equal to percentage 5D comma A comma B, right? Before swapping also you can print it. After swapping you can print it. Yeah. Now what you can do, I can say you are not returning anything. That's why I can say void swap of int. Can I use same A comma B? Yeah, you can use int A comma B. Otherwise, you can use, X comma Y also. Anything, okay? But both are local to the function only. Okay. Now int temp. I can say how can I swap? Temp equal to A equal to B, and B equal to temp. And sometimes, they will ask, without using temporary variable, how can we swap? That is also one task. Without using temporary variable, how can we swap two numbers? That is the task to you for tomorrow's session. One task, and this is another task. Now here I'll show you the output, but I won't get proper output. That's what I'm showing you here. Today I won't get proper output. How can we make it swapping up these two? That is your task. Okay. How can we do that? Okay. By using pointers. Pointers, it is possible. By using pointers, it is possible. Okay. Without pointer, it is not possible. Okay. So this is also your task. You should do this. Okay. Now, and what is another task? Without using temporary variable, how can we swap two numbers? Okay. That is also another task. These two output I will tell you tomorrow. I'll continue with the output of these two programs. I'll continue with the next session. So meanwhile, I can just save this. Yeah, this is another no, without using third variable. Sorry. So we should not use A, right? Local variables are, X and Y we are using. Local variables are X and Y. Y equal temp, temp equal to X, X equal to Y, temp equal to Y, right? Okay, these are the local to this. Yeah. Yeah. After swapping, what is the value? A equal 10, B equal 20. So before swapping also display it. So before swapping function, A value is what, B value is what. After applying swapping function, what is A value, B value, right? That is what I want to prove you. Yeah. So A equal to 10. Before swapping, A equal to 10, B equal to 20. After swapping, A equal to 10 and B equal to 20. That means swapping was there, but not happened, right? Yeah. For your better understanding, what I can show you. So, if I print here, what is the output? If I print here, is the swapping function is not work? My swapping function is correct only. My swapping function is correct only. See here, I'll show you. Within swap function, what is X and Y? Printf %5d space %5d comma X comma Y. Okay. So within swap function, my variable should be swapped or not. That also I'll prove you. Okay. See here, before swapping function A equal 10, B equal 20. Within swap function 2010. See, within swap function 2010. After swap function 1020 only. That means what? See, after function you are calling, right? That's why after function you are coming over here. Then after function you are coming over here. I just displayed here. Within function the value is 10 to 2010 only. Then again after calling this function here I printed, right? After swapping function the value became 1020 only. Then why it was happened? So here it was changed. but why it is not changed here? Those are why whenever we are calling the function, for what function purpose we are calling the function, whatever the function returns some results, those results should be printed in my main program. That is the purpose we are calling function, right? The result of these functions we should display in the main program. That is the purpose. But the result here is okay, 20 and 10, but those results are not affected in the main program. Are you clear? Yeah. So directly again, I got only 10 and 20, A and B values. Yeah. So that is a disadvantage. How can we? It is possible. Since here I am not returning, I can't return two variables values, but this how can we achieve? Okay. These programs can be achieved by using pointers if you deal with the address. Okay. Yeah. That you practice. And in the next session, I'll tell you this. Okay. Meanwhile, you should practice. Till then, happy learning. Yeah, thank you very much. Now I'm going to stop the session. Yeah. Hello, thank you, ma'am. Hello, ma'am. Yeah. Please practice those assignments and these programs. Next class, these solutions and the continuation with this is memory allocation, dynamic memory allocation. Here, of course, what are the topics are coming? That is very important. And in the last session, I can give you a small project, like a very good application. Okay. Yeah, thank you. I'm going to stop the session now.
Okay, sir. Thank you.
Yeah, thank you, ma'am. Yeah, I'm going to leave the session, madam.
Oh, okay, sir. Okay, sir. Please.
Yeah.